Okay, so now we've gone through the basics of integration, we're going to go through some more complex examples. And these complex examples are important because these are the harder questions that you're going to see in your exams. So right now we're going to go through some basic rules that we're going to be using in these complex examples. So let's have a look on the board here. Here we have the integration of a surd. And now when we try and integrate or even differentiate a surd, we can't do it in the surd form. What we have to do is change it into the index form. And this is just a reminder of how we do that. So here you see we have the integration of x to the power of n and to the root of n. And we can change that into x to the power of m on n. And how I remember what goes on top as a numerator and what goes on the bottom as a denominator is you can think of it as this is the root, this n here, that is the root, so that's going to go on the bottom, whereas you can see it's actually x to the power of m. So can you see how the m is on top as a power and the n is on bottom as a root? So that's how I remember it. The power on top and the root on the bottom. So you have x to the power of m on n. Okay, so that's something that's good to know for these complex examples. Now, the next rule that we need to go through for complex examples is this rule over here, where we have the integration of 1 on x to the power of m dx, which equals to x to the power of negative m. So when we have x to the power of anything on the denominator, so on the bottom of a fraction, we can't integrate it straight away. What we need to do is change it into the negative index first, as you see here, before we can integrate. But with both these rules, here we would change it to the negative index, and here when we change from the surd to the index form, remember in your final answer, we must switch back to the original format that the question is in to give the answer. So if you change it into the index form here, in your answer we have to change it back into the surd form, and the negative index we have to change back into the fraction form. Okay, let's go through some questions together now. So just a reminder to everyone, there is the standard formula up here. If you do get confused, it's just a good reminder to have. All right, let's have a look at question 8 now. So in question 8 we want to find the integration of 6 square root x dx. Now, before we move on to the square root, we just have to consider the 6. So I've been teaching you so far that we move the 6 to in front of the integration like this. But if you can think of this in your mind, you don't need to write out this step. You can just think of it as 6 multiplied by that later on. So it's really up to you if you want to write out this step or not. Okay, now let's deal with the square root. So this is in surd form and we have to change it into the index form. Now, we know that the square root becomes 1 on 2, and why that is because this is to the power of 1, x to the power of 1, and to the root of 2. And remember how I said the numerator, what goes on top, is always the index, and what goes on the bottom is the root. So we have 6 integration of x to the power of 1 on 2 dx. So now we just add 1 like we always do. So we're going to have x to the power of half plus 1 divided by the index plus 1, as we have here, half plus 1 plus the integral c multiplied by the 6 out here. Okay, so now we just need to simplify a little bit. So we have half plus 1, which is the same as 3 on 2. So we just write it as x to the power of 3 on 2. And over here we have 1 on 3 on 2. Now I'll show you what that becomes. So this is the same as you can imagine 1 divided by 3 on 2. And you know that when we want to change the divided by to the multiplied sign, we flip it. So that becomes 1 times 2 on 3, which gives us just 2 on 3. Now you can see that 1 on that fraction essentially just becomes the flip of that. So it becomes 2 on 3 here. So you don't always need to go through this process here to know that's going to be 2 on 3, but it's good to know how we get there. Okay, so now that you know that, we can go straight away. Well, 1 on 3 on 2 just means that we can flip the bottom fraction. So that becomes 2 on 3. So now we have 6 times 2 on 3, x to the power of 3 on 2. Now remember how I said before, when we change it into the index form, we always have to change it back into the surd form. So this is what we're doing here. We have Remember how I said 3, the numerator, that's the index, whereas 2 is the denominator, which is what is the root. So that is just the root there, but when we have root 2, we don't need to write the 2, it is just the root. And now we just simplify. So the 3 will cancel with the 6, and that's just going to leave us with 2 here. So now we have 2 times 2 square root of x to the power 3 plus c. And now it's just a matter of multiplying it all out together. So we get 2 times 2, which gives us 4, square root x to the power 3 plus c. Okay, so always remember your integral constant there. So important things to remember for this question is that when you have the square root or anything of an x, the first thing you have to do is change it into the index form, which is what we have done here. Once it's in index form, we are able to integrate it. But you have to remember to always put it back into the third form, okay, as we do down here. And once you do that, that's your final answer, as long as we always remember the plus c. Okay, all right, let's go on to the next question now. So in question 9, it's going to be similar to question 8, except a little bit more complicated in the way that we have the integration of the cube root of 2x to the power of 5 dx. Now, we have the 2 inside, so that makes things difficult because we can't really take that 2 outside by itself. So what we need to do is actually split up the surd. So what I mean by that is you can remember how we can separate surds as long as we keep the cube roots the same out here. So that we've just separated into the cube root of 2 multiplied by the cube root of x to the power of 5. And now this over here, the cube root of 2, is just like a number that we can take out the front. It looks more complicated, but essentially it really is just a number. So in that way, we can just take that out the front. So we'll have the cube root of 2 multiplied by the integration of the cube root of x to the power of 5 dx. Just like that, okay? All right, and now we need to change this into the index form. We don't need to change that into the index form because that's just a number. So remember that, okay? This can just stay out the front like that. We only need to change the x into the index form. So how do we know what goes on top? So remember the index goes on the top and the root goes on the bottom. So now we have x to the power of 5 on 3. So we're actually just integrating now x to the power of 5 on 3. That's the only part we're actually integrating because this is just a number out the front, okay? And same thing as we always do with integration, we add 1 to the index. So now we have 5 on 3 plus 1 divided by 5 on 3 plus 1 multiplied by the number out the front, which is what we have here. And now we just simplify. So 5 on 3 plus 1 is just going to be 8 on 3. And 5 on 3 plus 1, here we go, is 8 on 3. Now remember how I said before, 1 on any fraction just becomes the reciprocal of the bottom fraction. So it actually just becomes the bottom fraction flipped. Remember how I explained that before? So we know that this is just going to be 3 on 8, which means it's going to be 3 cube root 2 on 8 multiplied by x to the power of 8 on 3, as we have here. But we can't leave it in the index form. I can't stress that enough. We have to put it back into the original format. And it's such an easy thing to do, and you don't want to lose marks or something silly like that. So remember how the index goes on top and the 3 goes on the root here. So we have x to the power of 8 cube root. So your final answer should be 3 cube root 2 on 8. And the cube root of x to the power of 8 plus c. So the important things to know from this question is that when you have a number within the root itself, you need to split it up into separate surds. And in that way, when you have the number within the root, that's just a number anyway. So you can take that at the front like we did over here, and then you just concentrate on the root of the x. Change that into index form, integrate that, always go back to the original form and never forget your integral c. Okay, so just remember original form and always add integral c. Okay, let's go on to question 10 now. So, question 10, we want to find the integration of 14x cubed minus 9x over the square root of x dx. Okay, so this is going to be a little bit complicated, but let's just work through it step by step and we can always get the answer from that. So looking at this, what is the first thing that we have to do? So we've done a question similar to this before. Remember how I said if the denominator is by itself and there's multiple numerals, we can always separate the fraction. So that's exactly what we want to do here. We want to separate the fraction into 14x cubed on square root x and negative 9x on square root x. And because they're both quite complicated, it's just easier to think about it as two separate integrations. Remember how I've said that before? When you get fractions added together, you can just think about them separately and then remember to put them all together at the end and plus c. So this is exactly what we've done here. We separated the fraction. We're considering them separately because it's complicated. Now, let's do what we always do. We can always make this into the index form. So square root x we know is x to the power of half. Here we have x to the power of half. What we can also do is move the 14 and the 9 out to the front. So we will actually have 14 at the front like that. So now we just have to consider the x's. Same thing here, we can move 9 out the front. So then we just need to consider the x. Now we can simplify these x's, can't we? Because we remember that when we divide within the x, what happens to the indices? Exactly, this how you should subtract. So what you can do is subtract the indices. So remember, division between them gives us subtraction of the indices. So we have 3 minus half here. And here, remember, x is just x to the power of 1, 1 minus half. So now we are up to this step here. We have 3 minus half, that's going to give us 2.5, so 5 on 2, and 1 minus half, which is going to give us just half, okay? So we can write it as 14 integration of x to the power of 5 on 2, which is 3 minus half, and half, which is just 1 minus half. So can you see how we've gone from this, which we have no idea how to integrate, to something which we can actually integrate now? Because now we only need to consider really is the integration of x to the power of 5 on 2 and x to the power of half. And to integrate that, we do as we normally do, which is we need to add 1 to them. Remember, with integration, you always add 1 because it's the opposite of differentiation. So we add 1 to the 5 on 2. So we have 5 on 2 plus 1. We always divide by exactly the same, the index plus 1. And here we have half plus 1 divided by exactly the same, which is half plus 1 and plus integral c. And now all we need to do is simplify a little bit. So we know that 5 on 2 plus 1 is just going to be, exactly, it's going to be 7 on 2. And here we have 1 on 7 on 2. Half plus 1 will give us 3 on 2. So we have x to the power of 3 on 2. And now we have 1 on 3 on 2. Remember how I was teaching you before, if we have 1 on a fraction, because of the rules of how we flip it when we go change from division to multiplication, 1 on a fraction just gives us the reciprocal of the denominator. So it actually just gives us the denominator flipped over. So here we have 7 on 2. So it's on the bottom and we want to change it, it becomes 2 on 7. And similarly, 1 on 3 on 2 becomes, when you flip it, just 2 on 3. So therefore, we actually have 14 multiplied by 2 on 7 because it's just the 7 on 2 here flipped. And here we have negative 9 multiplied by 2 on 3 because it's just the 3 on 2 flipped over. Okay? And here we've just changed it into the third form. So you can see here we have x to the power of 7 on 2. So 7 is the index, 2 is the root, which we don't need to write. 3 on 2, so 3 is the index up here, and 2 is the root, which we don't need to write. But finally, we just need to cancel down a bit more. So we know the 7 and the 14, they're going to cancel out. So that leaves us with 2 there. And the 3 and the negative 9 will cancel out, and that will just leave us with negative 3. Just be really careful not to forget your negatives when you're cancelling. It's easier to just go 9, 3, okay, it becomes 3 and make into a positive. So just be really careful with that. So finally, we should get our answer as 2 times 2, which gives us 4, square root of x to the power of 7, minus 3 times 2, which gives us negative 6, square root of x to the power 3 plus c. Okay, so you can see it is quite a long question, but we've actually only gone through it step by step, and therefore it's actually not that difficult. So remember, let's go through this again. The first thing we want to do is when you see the denominator by itself and multiple numerators, we split up the fraction. And then we can always take out the number out the front over here, and then we just simplify the x's from the surd form into the index form. And now we simplify this, so we have 3 minus half, 1 minus half, and once we get to this stage, we know exactly what to do. We can just add 1, exactly like we've done here. And just remember to always put it back into the original surd form as your answer and plus the integral c. Okay, all right, so that was quite a difficult question that we all went through. So just take a minute, have a look here. All right, okay, so now we're going to move on to the next question. So that was a very difficult question. We're going to look at question 11 now, where we're going to find the integration of 1 on 4x squared minus 2 on 3x squared dx. So in this one, we don't need to separate the fractions. They've actually done that for us already over here. But what we do have is we have fractions, and we also have on the denominator the x, which means we're probably going to be working with negative indices here. So we can change the x to the power of 2 into x to the power negative 2, and here the x to the power 3 on the bottom as a denominator we change to the negative index, so x to the power of negative 3. And now we just consider each one separately. So we just considered this one over here. So what we've done is we've just taken the 1 on 4 out the front. So we don't need to actually write that step in every single exam question, but you just need to know how it works. We can go straight from this step to this step because we know that when we take 1 on 4 out the front, we're just multiplying it by the integration of the x, which means that we can actually just move from this to this to this and go straight from that to that step where we have 1 on 4 multiplied by the integration of this, which is minus 2 plus 1, divided by minus 2 plus 1. So same thing here, we don't actually need to write out this step, we just consider it. We have negative 2 on 3 multiplied by the integration of x to the power of negative 3. So here we have negative 2 on 3 multiplied by x to the power of minus 3 plus 1, divided by minus 3 plus 1, plus integral c. And now once again we just simplify. So we know that x to the power of minus 2 plus 1, that's going to give us x to the power of minus 1, and 4 multiplied by negative 2 plus 1, so that just becomes negative 1, so that becomes negative 1 on 4. And over here we have x to the power of negative 3 plus 1, which becomes x to the power of negative 2. Negative 3 plus 1 becomes negative 2 multiplied by 3. But the negative 2 here, as you can see, will just cancel with that and leave us, importantly, with negative 1. So don't forget about that negative. So if we have a negative 1 here and we have a minus sign here, they'll combine together to give us a positive, which is why we have plus 1 on 3x to the power of negative 2. Okay, so it's really be careful with your signs. They're just too easy a mistake to make, and you don't want to be making those mistakes. And now, is this our final answer? No, it can't be, because we have to change it back into the fraction format. So remember, always change it back to the original format. So this becomes 1 on x, and this will become 1 on x squared. So your final answer should just be 1 on 4x, negative 1 on 4x, plus 1 on 3x squared, plus the integral c. So the important things to remember for this question is to be careful with your signs, and also just remember that when you have the fractions like this, you want to change it into the negative indices like we have done over here. So remember, when you see x as denominator, always move it up the top with a negative index. Okay, so that was question 11. Now we're going to move on to question 12. So in question 12, we want to find the integration of x squared bracket x minus 4 dx. And there's no chain rule, there's no product rule that we have in differentiation. We don't have that in integration. So what we just have to do is to just expand it. Okay, so remember, with expanding, we just go x squared multiplied by x, and then we have x squared multiplied by negative 4. So that should give us x to the power of 3 minus 4x squared, like we have over here. And once again, when we integrate, just consider them separately. Just consider it as integration of x cubed minus integration of 4x squared. And like we always do in integration, we add 1. So here we have 3 plus 1 divided by 3 plus 1 minus 4x to the power of 2 plus 1 on 2 plus 1. Notice how we're not doing the step where we take the 4 out and then bring it back in, because we can also just imagine that in our minds where we're already just doing that. So it's just 4 multiplied by that. Okay, and now we just need to simplify. So we're going to have x to the power of 4 on 4 minus 4x to the power of 3 on 3. And always check your answer to see if there's something that you can simplify. So in this case there's not, and you always check if you've added the integral c. So remember, always check, number 1, if you can simplify more, and number 2, always check if you've added the integral c in this case. And remember, there's no product rule or chain rule in integration. So if you get a bracket like this, the only thing we can do is expand and then integrate. All right, let's move on now to question 13. So in question 13, this is quite similar to question 12, where we have brackets. So like I said before, with brackets and integration, you just have to expand. And can you see something here that makes our life quite easy when we're expanding? Exactly, it's a difference of 2 squares. So remember, when we are expanding a minus b, a plus b, it just becomes a squared minus b squared. So therefore, if we're expanding x minus 1, x plus 1, like we are doing here, it becomes x squared minus 1. So therefore, we just have the integration of x multiplied by x squared minus 1, which means when we expand that, it's going to be x times that, which gives us x cubed, minus x times that, which gives us minus x. So that's how we get the integration of x cubed minus x. Okay, and now that we should know what to do, we just consider them separately. So first of all, with the x cubed, we just add 1 to the cubed. So we have x to the power of 3 plus 1 on 3 plus 1, minus x to the power of 1 plus 1 on 1 plus 1, plus the integral c. And now it's just a matter of simplifying. So we have x to the power of 4 on 4, minus x to the power of 2 on 2, plus the integral c. So once again, check, can we simplify that anymore? No, we can't. There's nothing we can cancel or simplify. Have we added the integral c? Yes, we have. So therefore, that should be our final answer there. So just remember, when you see brackets in integration, we always expand, exactly. And we always check the final answer to see if we've added the integral c and whether we can simplify any more. Okay, let's move on to question 14 now. So in question 14, we want to find the integration of the square root of x multiplied by x plus 3 dx. So in this one, we're combining what we've done before, which is surds, as well as with the brackets. So first thing with brackets, we know we have to expand no matter what in integration. So let's just expand this. And don't worry about the fact it's a surd, just expand as you normally would. So we have square root x times x plus 3 times square root x. Okay, and now since they are in surd form, we can't do anything, so we have to change into index form. So we've changed x to the power of half here, and this becomes x to the power of half as well. And now we remember then when we multiply the x's, what happens to the indices? Exactly, they get added together. So remember, there's actually a 1 up here like that. So we actually have x to the power of half multiplied by x to the power of 1, which means that this becomes x to the power of half plus 1, which is how we get x to the power of 3 on 2 that we have over here. Now, 3 is just a number, so when we multiply together, this just becomes 3 to the power of x to the power of half. Now, we've gone from this step to this step, and once we get here, we know that we will be able to integrate. So let's do that now. With integration, remember what we do. We always plus 1 to the index. So we have 3 on 2 plus 1 divided by 3 on 2 plus 1. Here we have 3x to the power of half plus 1 divided by the same and plus the integral c. So now we just need to simplify. So when we simplified this, we have 3 on 2 plus 1, which is just 5 on 2. And then we divide by the same. And then we have half plus 1, which is 3 on 2. And that's how we get 3x to the power 3 on 2 on 2 plus c. And remember how I was saying before, if you have 1 on 5 on 2, what does that become? Exactly, it should become 2 on 5, like that. So you can see this will become 2 on 5, and this will become 2 on 3. So you can see we have 2x power 5 on 2 on 5, plus 2 times 3, that's already up there, on 3, x to the power 3 on 2 plus c. And you can see that 3 and that 3 should cancel, and that should leave us with this. But is this going to be our final answer? No, exactly, it can't be, because we always have to change it back into the original format. So that's what we've done here. We've cancelled out the 3's, and we know that 5 on 2 is the same as writing x to the power of 5, square root of that. And x to the power 3 on 2 is the same as writing x to the power of 3 square root. And remember, that's because the numerator up here is always the index, and the denominator, so the number on the bottom, is always the root. So once again, we check, is the integral c there? Yes, it is. Is this as simplified as we're going to get? Yes, it is. So once you've checked that, you know this is going to be your final answer. So just a little revision of this question. Remember that with brackets we expand, and it doesn't matter how difficult the bracket looks. And always with surds we change it to index form. So here we're actually combining two of the things that we've been talking about into one question. And as you can see, it may look complicated, but each step makes sense and it's actually quite simple when you go through it step by step. Okay, let's move on to the next question now. Alright, so in question 15, we want to find the integration of x squared plus x, the whole thing squared, dx. And what we want to do here is we want to expand it so we're able to integrate it. So to expand that, there's a couple of ways that people do it differently. So you can either consider it as two separate brackets. So we have x squared plus x, bracket x squared plus x. And you consider it as this x squared multiplied by this one, plus that multiplied by that, plus x times x squared here, and then plus x times x. Or some of you may have learnt what you do is just go x squared multiplied by itself here, plus 2 times x squared multiplied by that, plus x multiplied by itself there. Okay, so that's how we get x squared times by itself is x to the power of 4. X squared times x gives us x cubed, and remember it's 2 times that, so you have 2 times x cubed here, and then x multiplied by itself, which gives you x squared. And that's how we get to this stage here, which is the integration of x to the power of 4 plus 2x cubed plus x squared dx. And once we get to that stage, we know that we can actually integrate from there quite simply, just considering each section separately. So we integrate x to the power of 4 first, where we add 1 to the index. So we have x to the power of 4 plus 1 on the same. So 2x to the power of 3 plus 1 over exactly the same. And here we have x to the power of 2 plus 1 on exactly the same, and remember plus the integral c. And now we just simplify. So we know that becomes x to the power of 5 on 5. This becomes x to the power of 4 on 4 multiplied by the 2, the number in front, plus x to the power of 3 on 3 over here, plus the integral c. And now remember, at the end of every question we do a couple of things. First of all, is it as simplified as we can get? Second of all, is the integral c there? And third of all, is it in the original format? Well, this one wasn't in surd or in fraction format, so we don't have to worry about that. And yes, there is an integral c there, but we can simplify more. So here you can see the 2 and the 4 can cancel out to leave us with 2 on the bottom. So our final answer should be x to the power of 5 on 5 plus x to the power of 4 on 2 plus x to the power of 3 on 3 plus integral c. So important things to know for this question is that you should always check what can be simplified, and sometimes it's not a large thing that can be simplified. It might just be one of the fractions, which is what we have here. So just always check those 3 things at the end of every question and you know you won't be missing anything. Okay, so that was question 15. Let's move on to question 16 now. All right, having a look at question 16, we want to find the integration of square root x minus 2, the whole thing squared dx. So exactly the same before, we want to expand it and then we want to integrate. So remember how one of the ways to expand, as I taught you before, is we take the first number and we square it or multiply it by itself. So that's going to give us x. And then we take the first number multiplied by the second number times 2. So we have square root x times itself, so squared, minus 2 times 2 square root x. And then finally, we have negative 2 squared. So that should leave us with, this just becomes x. This becomes negative 4 square root x. And this, because it's negative 2 times negative 2, that's why we actually have plus 4 here. Okay? And once we get to this step, what do we need to do? Exactly, the surd here needs to be changed into index form. So that's exactly what we've done. We've changed a square root x into x to the power of half. So now we have x minus 4x to the power of half plus 4. And we can integrate this quite simply. So here we have x to the power of 1 plus 1 on the same. Here we want to integrate x to the power of half, so we have half plus 1 on half plus 1. And here, remember when we integrate a number, whether it's 4 or 5 or whatever number it is, you just add x, so it becomes 4x. Remember how I explained that before? Exactly. So now let's just simplify a bit. So we have, that becomes x squared on 2. This becomes 4x 3 on 2. Half plus 1 is 3 on 2. On 3 on 2 plus 4x plus c. Now remember how we've been talking about 1 on 3 on 2? And all we need to do is just flip the bottom, so the reciprocal of the bottom. So that becomes 2 on 3. So this actually becomes x squared on 2. That 3 on 2 flips to become 2 on 3 multiplied by 4x 3 on 2 plus 4x plus c. And now we just simplify. So we know 2 times 4 gives us 8. Okay, this is all exactly the same. And is this our final answer? Remember the 3 things we want to check? Can you simplify it anymore? Well, looking at that, you can't simplify that, can't simplify that, so no. Is there integral plus c? Yes, there is. Is it in the original format? No. So that's what we need to do here. Change this into the original surd format. So remember how the top number is the index and the bottom number is the root. So our final answer should be x squared on 2 minus 8 on 3 times square root x to the power of 3 plus 4x plus c. Okay, so remember the 3 things we always want to check is, first of all, can we simplify it anymore? Second of all, have I added the integral c? And third of all, is it back in the original format? And if you check those 3 things, you can be quite certain that this will be your final answer.